Hello, my name is Joshua Gavi. I welcome you to ionic chemistry and qualitative analysis. We are going to look at precipitation reactions in salt preparation. State what is observed when sodium hydroxide is added to the following solutions dropwise until in excess. What is observed when sodium hydroxide is added to the following solutions dropwise until in excess? Our ions, we have the solution of magnesium and a solution of aluminium sulfate. So we want to add there sodium hydroxide dropwise, and we observe, and then until in excess. We start with magnesium solution. In magnesium solution, when you add sodium hydroxide dropwise, you form a white precipitate. And this precipitate is insoluble in excess sodium hydroxide, meaning that the white precipitate formed by adding sodium hydroxide dropwise, it becomes insoluble even when we add excess sodium hydroxide. With aluminium sulfate, we form a white precipitate, and this white precipitate is soluble in excess, meaning that when we get aluminium sulfate and we add their sodium hydroxide dropwise, it forms a white precipitate. But when we continue adding in excess sodium hydroxide, the precipitate becomes soluble and it forms a colorless solution, which means that aluminium sulfate precipitates in sodium hydroxide and it dissolves in excess sodium hydroxide. Write the ionic equation for the reaction that occurs between magnesium and sodium hydroxide. Write the ionic equation for the reaction that occurs between magnesium and sodium hydroxide. So we are having our magnesium here, and we have added in sodium hydroxide, and we formed a white precipitate. Now we want to write the ionic equation for that reaction that took place to form a white precipitate. The ionic equation, we have the magnesium ions, which is aqueous. This one will react with the hydroxide ions, which are also aqueous, and we get magnesium hydroxide. Magnesium hydroxide is a solid, and this is the white precipitate that is formed in excess sodium hydroxide. We should take a note that zinc, aluminium, and lead, these are soluble in sodium hydroxide. So when we add sodium hydroxide to solutions of zinc, aluminium, and lead, they will form a precipitate which is white, and that precipitate dissolves in excess sodium hydroxide. So we have looked at magnesium and aluminium sulfate solutions. What happens when we add their sodium hydroxide dropwise until in excess? We have seen that in magnesium we form a white precipitate which is insoluble in excess sodium hydroxide, and we saw that for aluminium sulfate we form a white precipitate which is soluble in excess sodium hydroxide, and it forms a colorless solution. We have also noted that when we add sodium hydroxide dropwise till excess to zinc, aluminium, and lead, they form a white precipitate which is soluble in excess sodium hydroxide. Explain what will happen or what happens when dilute sodium hydroxide solution was added to zinc chloride solution. A white precipitate was formed. The precipitate dissolved in excess sodium hydroxide, forming a colorless solution. Let us repeat it and understand it well. We are going to explain what has happened. And what has happened is that dilute sodium hydroxide solution was added to zinc chloride solution. We formed a white precipitate, and this white precipitate later on dissolved in excess sodium hydroxide, forming a colorless solution. So we have to explain. A white precipitate that was formed is due to the formation of an insoluble zinc hydroxide. That is when sodium hydroxide was added to zinc chloride, we formed a white precipitate. This white precipitate that was formed was due to the formation of an insoluble zinc hydroxide. The zinc ions that are in zinc chloride solution reacted with the hydroxide ions that came from sodium hydroxide, and we formed a white precipitate. That white precipitate is the zinc hydroxide. That is our white precipitate that we formed, zinc hydroxide. In excess of sodium hydroxide, zinc hydroxide, being amphoteric, it dissolves to form a complex which we call zincate ion. So we see that here the zinc hydroxide which was formed, which is a white precipitate, this precipitate dissolved in excess sodium hydroxide and it formed a colorless solution, meaning that it formed a complex which is zincate ion, which is soluble. And if you look at our precipitate, we say that the precipitate is zinc hydroxide, which is solid. It is our white precipitate. This precipitate is the one that dissolves in excess hydroxide. So the precipitate, which is zinc hydroxide, when it gains excess hydroxides or in excess sodium hydroxide, it forms a colorless solution. And that colorless solution is our complex, which is we call zincate ion. And this is the formula of zincate ion, ZnOH42-. This is our zincate ion. It is aqueous. It is a solution, meaning that it is soluble. Zinc hydroxide is a solid, meaning that it is the precipitate. The colorless solution that we formed at the end is our zincate ion. Explain. A blue precipitate formed when ammonium solution was added to copper 2 sulfate solution. The precipitate dissolved in excess ammonia, forming a colorless solution. We want to explain. A blue precipitate was formed when ammonium solution was added to copper 2 sulfate solution. And that blue precipitate dissolved on addition of excess ammonia to form a colorless solution. The blue precipitate that was formed was due to the formation of an insoluble copper 2 hydroxide. So we had a blue precipitate which was formed when ammonium solution was added to copper 2 sulfate solution. That precipitate that was formed was copper 2 hydroxide. It is the one that formed the blue precipitate. So the copper 2 ions that came from copper 2 sulfate reacted with the hydroxide ions that came from ammonium solution, and we formed copper 2 hydroxide. Copper 2 hydroxide is a solid, and that is what formed what we call the blue precipitate. The blue precipitate is copper 2 hydroxide. That is our blue precipitate that was formed. In excess ammonia, the copper 2 hydroxide, being amphoteric, dissolves, forming a complex. That complex is tetraamine copper 2 ions. So what we are saying is that we formed the copper 2 hydroxide, which is a blue precipitate. But when we added excess ammonium solution, the precipitate formed a colorless solution. And that colorless solution is a complex. That complex is the one we call tetraamine copper 2 ion. So when you look at the equation, this is copper 2 hydroxide, which is our precipitate. We have formed the blue precipitate. Now, when you add excess ammonium solution, we form a complex, which is tetraamine copper 2 ions. And this one is what forms a colorless solution. Our copper hydroxide is a blue precipitate, which is solid. But being amphoteric in nature, it will dissolve in excess ammonia due to the formation of a complex which we call tetraamine copper 2 ions, which forms a colorless solution. Write ionic equation for the reaction that occurs when the following pair, between the following pair. Write ionic equation for the reaction that occurs between the following pairs. We have iron 3 sulfate and ammonium solution. We want to write the ionic equation that takes place between the reaction of ammonium solution and iron 3 sulfate. Then we shall also write the ionic equation for the reaction between calcium nitrate and sodium hydroxide solution. They want us also to write the ionic equation between the reaction of barium chloride solution and sulfuric acid. We shall also write an ionic equation between silver nitrate solution and dilute hydrochloric acid. So we want to write the ionic equation between the reactions of iron 3 sulfate with ammonium solution, silver nitrate solution and dilute hydrochloric acid, calcium nitrate and sodium hydroxide solution, and barium chloride solution with sulfuric acid. We shall start with iron 3 sulfate and ammonium solution. The iron 3 sulfate will provide the iron 2 ions in aqueous form, and the ammonia will provide the hydroxide ions in aqueous form, and we shall form ion 2 hydroxide, which is a precipitate. That's why we've written solid. There is precipitation. Silver nitrate solution and dilute hydrochloric acid. Silver nitrate solution will provide the silver ions Ag plus in aqueous state, and the dilute hydrochloric acid will provide the chloride ions. Chloride ions will react with silver ions to form silver chloride, and silver chloride is a precipitate. That's why we write a solid. Then we have calcium nitrate and sodium hydroxide solution. Calcium nitrate will provide the calcium cations, and sodium hydroxide solution will provide the hydroxide ions. The calcium cations and hydroxide ions will react together to form calcium hydroxide, which is a precipitate. And lastly, not the least, we have barium chloride solution and sulfuric acid. Barium chloride will provide the barium ions, and then sulfuric acid will provide the sulfate ions. Barium ions will react with the sulfate ions to form the barium sulfate, which is a precipitate solid. So that is the reaction between iron sulfate with ammonium solution, the ions and hydroxide to form iron hydroxide. We have silver nitrate reacting with hydrochloric acid, getting the silver ions, reacting with the chloride ions to get silver chloride. We have barium chloride reacting with sulfuric acid, barium cations reacting with sulfate ions to form barium sulfate, and then we have calcium nitrate reacting with sodium hydroxide to form calcium hydroxide from calcium cations and hydroxide ions. Thank you very much for participating in ionic chemistry and qualitative analysis, precipitation reaction in salt preparation.